Hi friends! We have a brand new amazing video on the largest star in the universe. Therefore, like the video and subscribe to our YouTube channel before it starts to see more. Stephenson 2-18, often referred to as Stephenson 2-DFK1 or RSGC 2-18, is a red supergiant, RSG, or possibly an extreme red hypergiant, RHG, star in the constellation Scutum. Its name is shortened to ST 2-18. It is assumed to be one of a group of stars at a similar distance because it is situated close to the open cluster Stephenson 2, which is about 5.8 kiloparsecs, 19,000 light-years, away from Earth in the Scutum Centaurus arm of the Milky Way galaxy. However, some sources believe it to be an unrelated red supergiant. It is one of the Milky Way's brightest stars, one of the biggest known stars, and one of the most brilliant red supergiants. According to calculations, Stephenson 2-18 has a radius of about 2,150 solar radii, 1.50109 kilometers, 10.0 astronomical units, which translates to a volume that is almost 10 billion times larger than the Sun. If this calculation is accurate, it would take about 9 hours to orbit the Earth at the speed of light as opposed to 14.5 seconds for the Sun. Its photosphere would encompass Saturn's orbit if it were positioned at the center of the solar system. History of observations. In 1990, American astronomer Charles Bruce Stephenson found the open cluster Stephenson 2 in data from a deep infrared scan. The cluster, sometimes referred to as RSGC2, is one of several huge open clusters in Scutum that are home to several red supergiant stars. The first investigation of cluster member attributes assigned the number 1 to the brightest star in the cluster's area. Due to its remote location, unusually high brightness, and slightly anomalous proper motion, it was classified as an independent red supergiant and was not thought to be a part of Stephenson 2. Later research awarded the same star the number 18 and placed it in the Stephenson 2SW outgroup of stars, which was thought to be around the core cluster. The star is frequently referred to as SC 2-18, short for Stephenson 2-18, using the Degachi numbering as a guide, 2010. The designations from Davies, 2007, are sometimes given a prefix of DFK or D, for example, Stephenson 2-DFK1. This is done to minimize confusion caused by using the same number for multiple stars and different numbers for the same star. In a research on the maser emissions from red supergiants throughout the galaxy, Stephenson 2-18 and 56 other red supergiants were observed in 2012. The Australia Telescope Compact Array, ATCA, and the Dusty model were used in the study to extract the characteristics of those red supergiants. One of the red supergiants mentioned was Stephenson 2-18. It was spotted once more in the same year to research the types of masers found on red supergiant stars in clusters. In a study on the red supergiants in Stephenson 2, Stephenson 2-18, also known as D1, was discovered in 2013. The star was referred to as a very late-type red supergiant in several following investigations. Humphreys et al., 2020, also referred to it, however they misidentified it as RSGC 101, another sizable and bright red supergiant in the constellation of Scutum. Distance. Stephenson 2, and by extension, Stephenson 2-18, were first considered to be located at a distance of about 30 kiloparsecs, 98,000 light-years, when the cluster was first identified in 1990. This is a significant distance from where the cluster is now believed to be. Assuming that the cluster stars were all M-type supergiants, the distance modulus was computed using the typical absolute magnitudes of the cluster stars to arrive at the bigger distance. The distance of the stars in the cluster was calculated by Nakaya et al. In 2001 to be 1.5 kiloparsecs, 4,900 light-years, which is a lot closer than any other distance estimate for the star and the cluster. Alternatively, research conducted around the same period provided a second distance of approximately 5.9 kiloparsecs, 19,000 light-years. Stephenson originally stated a distance of 30 kiloparsecs, 98,000 light-years, however a study from 2007 calculated a kinematic distance of 5.83 plus 1.91 0.78 kiloparsecs from a comparison with the cluster's radial velocity. Its distance was not directly calculated, though, due to Stephenson 2-18's dubious membership. Later, this value was used in cluster research that was recently conducted. According to a 2010 study, the cluster is located close to the Scutum Centaurus arm of the Milky Way at a distance of 5.5 kiloparsecs, 18,000 light-years, which was calculated using the average radial velocity of 4 of its members, 96 kilometers per second, and in association with a group of stars near Stephenson 2, Stephenson 2SW. This value was then utilized in a 2012 study that calculated the star's luminosity using the aforementioned distance, but highlighted that there was a larger than 50% degree of error in the measurement. The distances to big star clusters, however, will supposedly get closer in the future. Verheyen et al., 2013, calculated the cluster's kinematic distance as being approximately 6 kiloparsecs, 20,000 light-years, away using the average radial velocity of the cluster, plus 109.30.7 kilometers per second. The radial velocity of Stephenson 2-18, however, is only estimated to be 89 kilometers per second. Physical characteristics. Estimates of the 2012 bolometric luminosity and effective temperature of Stephenson 2-18 were obtained using the Australia Telescope Compact Array. SA2-18 exhibits the characteristics and features of an extremely bright red supergiant and has an uncommon, for supergiant stars, M6 spectral type. This makes it one of the Milky Way's most intense stars. The Hertzsprung-Russell diagram's upper right corner, where it is located, is dominated by unusually massive and bright low-temperature stars. Typically categorized as a red supergiant, Stephenson 2-18 has a broad line profile. The authors of Davies, 2007, speculate that the star may be a red hypergiant like VY Canis Majoris due to its considerable infrared excess. The development of Stephenson 2-18 into a luminous blue variable, LBV, or Wolf-Rayet star is also claimed to be imminent, WR star. Brightness. According to one calculation, the star has a luminosity of over 440,000 L when the spectral energy distribution, SED, is fitted with the dusty model. A different, older calculation from 2010 that uses 12 and 25 m flux densities and still assumes membership in the Stephenson 2 cluster at 5.5 PCS results in far lower and more modest brightness of 90,000 L. More recent computation results in a bolometric luminosity of 630,000 L using SED integration, based on published fluxes, and a distance assumption of 5.8 kpc. Its SED, however, has drawn attention since it exhibits fluxes that don't conform to the acknowledged range of acceptable temperatures for an RSG or a typical reddening law. It would be even more brilliant if this implied a higher extinction. It has been questioned if the star belongs to the Stephenson 2 cluster because of its exceptionally high brightness. The stellar relationship spans a vast area, as shown in Negerwela et al., 2012. Temperature. A 2012 study utilizing SED integration and the Dusty model computed an effective temperature of 3,200 K, which is far lower than the lowest red supergiants anticipated by stellar evolutionary theory, typically around 3,500 K. Based on its spectrum and other spectral properties, Negerwela et al., 2013, determined that Stephenson 2-18 has a spectral type of roughly M6, which is rare for even a red supergiant star. TO spectral lines are among the characteristics of Stephenson 2-18 spectrum. Size. A bolometric luminosity of nearly 440,000 L and an estimated effective temperature of 3,200 K were used to derive a radius of 2,150 R, 1.50109 kilometers, 10.00, 930 million miles, which is significantly larger than the theoretical models of the largest red supergiants predicted by stellar evolutionary theory, around 1,500 R. It would be bigger than other well-known red supergiants like Antares A, Betelgeuse, VY Canis Majoris, and UY Scuti if this number is accurate. Stephenson 2-18 has one of the largest mass loss rates of any red supergiant star, with an estimated rate of about 1.35 m per year. Given its large infrared excess, Stephenson 2-18 might have just had a severe mass loss episode. According to a 2013 paper outlining the red supergiants in Stephenson 2, D1, also known as Stephenson 2-18, and D2, another member of Stephenson 2, have the largest mass losses in the cluster based on maser emissions. Only the stars in the cluster with the highest bolometric brightness appear to have maser emissions. Strong silicate emission is visible in Stephenson 2-18, notably between the wavelengths of 10 and 18 m. Additionally, water masers were found in the star. Membership. If this star genuinely belongs to its purported cluster has been a subject of discussion for some time. Some sources claim that the star is unlikely to be a foreground giant because of its lower radial velocity than the other cluster stars, while more recent articles regarded the star to be an unlikely member because of its extreme and contradictory characteristics. A study of red supergiant masers in massive clusters used radial velocities derived from CO maser emission and IRCO absorption to classify Stephenson 2-18 as a field red supergiant, distinct from Stephenson 2 due to its lower radial velocity that is noticeably different from other stars from Stephenson 2. Unfortunately, membership in Stephenson 2-18 cannot yet be ruled out. Another theory is that Stephenson 2-18 is truly a member since an expanding optically thick envelope cancels out its radial velocity. After all, red supergiants typically have an outflow speed that is 20 km per second faster than the distance between this star and Stephenson 2 itself. According to a different analysis, Stephenson 2-18 is a member of the Stephenson 2SW cluster, which is believed to be connected to the core cluster and to include multiple massive stars and red supergiants. Uncertainty. The highest stellar radii anticipated by the stellar evolutionary theory are expected to only be around 1,500 R, hence the radius of 2,150 R may be an overestimate. Stephenson 2-18's distance has been said to have a relative uncertainty greater than 50%. Estimates of the star's luminosity are also speculative. One estimate of its luminosity yielded a value of 90,000 L. Some scholars believe the star to be a red supergiant unrelated to Stephenson 2 or any of the red supergiant clusters near the base of the Scutum Centaurus arm due to the star's ambiguous membership, unclear distance, and different radial velocities from the rest of the stars in Stephenson 2. Future. Stephenson 2-18 is predicted to be on the verge of shedding its outer layers, at which point it will evolve blueward into a brilliant blue variable or a Wolf-Rayet star. This prediction is based on current stellar models and stellar evolution theories. Do you enjoy this video? Feel free to give your valuable feedback in our comment section. Also make sure to subscribe to our YouTube channel.